just take a outer diagram I'm trying to draw, nothing else. How it looks, and in between we are having like this. Okay, so this is generally from where here we are going to have hydrogen. Okay, and this is S block elements, and this is D block elements. This is a P block elements, and this is a F block elements. Okay, that means what we can say in modern periodic table. Okay, in modern periodic table, modern periodic table, how many groups are there? 18 groups are there, no?
Yes, sir. 18 groups.
Naming from
1, 2, 3, 4.
1 to
3,
up
4 to
to
18.
8. Okay, and now in the modern form of periodic table, and what there are 7 periods. Periods means horizontal rows, right?
Yes, sir. Naming from 1.
Okay, from 1 to 7. 7 it is going to have. And now, so this periodic table based on the, okay, electronic configuration also, okay, based on the electronic configuration also, it was divided into different groups. Okay, like groups and periods, that is in S block, P block, D block, and F block. That means what we can say. So in modern periodic table only, so based on the electronic configuration,
Sir, hydrogen is S block only, no, sir?
generally S block, nana, but it is differently considered different atom. Okay,
Okay, sir.
so I'm getting call. 1 second, students, please. Thank you, Rana. Now see here. So based on electronic configuration, okay, electronic configuration. Okay, we have, so that means periodic table classified into blocks like classified into blocks, that is S block, P block, D block, and F block. Okay, 1 second, let me show that periodic table also. Now you can see my screen, right? Hello, students, can you see my screen?
Yes, sir.
See, so see, this is now you can see green also, right? See here, groups are there. How it was there, first group, okay, which is also called as 1A group. See how my magnifier is there, no? Where it is magnifier is there, no? Curse. So where it is moving, you please see once. Okay. So these are the first group elements like hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. This is first group or 1A group also we can call. It is like alkali metals. Okay. And this is second A group. See here, second or second A group. So it was given a second A oblique. So that is beryllium, magnesium, calcium, strontium, barium, radium. These two together, we are going to say S block elements. Okay, no, no, no. Right? Now coming into this, see here. This is third group. So third to 12, 13th group if you observe. See, that is boron, aluminum, gallium, okay, indium, thallium, nihonium. Okay. Next, that is 13th group or 14th group. Next one is fourth group, that is carbon, silicon, germanium, tin, lead, fluorium, Fl. Next, nitrogen, phosphorus, arsenic, stibbium, bismuth, and moscovium. Okay. Oxygen, next that is 6th group. You can see now oxygen, sulfur, selenium, tellurium, polonium, and levoronium. Next, halogens. These are fluorine, chlorine, bromine, iodine, acetylene, and tennessine. Next one is helium, neon, argon, krypton, xenon, radon, and ogason. These are all inert gases are 18th group. These groups are called as what we can say P block elements. We can say that means P block elements from where to where? From third to 18th, 13 to 18th group. Now this is completely P block. Now here see D block elements. In between which I am able to see no see here where I am moving that like scandium, yttrium. Okay. Next it will have lanthanum and hafnium, actinium, titanium, zirconium, hafnium. Okay, that is fourth group or fourth B group also we can call. Fifth group, fifth vanadium like this. This is comes under D block elements. Okay, from scandium to Cn. And next one here. This is cerium to lutetium, or we can say lanthanum to also. These are all called lanthanides and actinides. From 89 to generally actinide starts from 90 to 103. Cerium starts from lanthanide starts from 58 to 71. Okay, these are called F block elements are also inner transition elements. Next one D block is also called as transition. This is like a modern periodic table and how it is shows. Okay, now based on this, if we are writing their electronic configuration of individual elements, okay, if we here electronic configuration was not shown, if we are trying to write the electronic configuration, if you observe, so beyond this it will not become magnified. Nana. So if you observe clearly, see in bottom their electronic configuration is given like 1s1, 1s2, 2s1. Can you see? Students, can you see, Nana?
Yes, sir.
Their configuration also given if you observe clearly. Okay. So based on that configuration only, we are writing their electronic configuration and how we are going to write. Let me see that one. Okay, I hope you understood what I'm trying to say. Okay, na, students. Now let's come to topic. Now, so as I'm saying that S block, no, so let me write the S block general characteristics and how it is going to write from where to where elements we are having. Okay. Generally, in S block, common electronic configuration of the elements. S block contains two groups, no, that is 1A group, which we have seen already, 1A group, which is also called as alkali metals, and we have second A group. This is also called as alkaline earth metals. So alkaline earth metals configuration general, it will have valence electron configuration, it will have NH2, and it will have NS1 configuration, it will be there. Okay.
Uh, uh,
Okay, students. So from this one, what we can write? General electronic configuration is general electronic configuration is generally we can write ns1 to 2. Ante s orbitals can be filled from either one electron or two electrons, it will be there. Okay. Now coming into p block. In p block, six groups are present. Six groups are there. That is what we can say. That is third A group, which is also called as boron family. And the configuration is NH2 NP1 for the boron family. And next one, fourth A group, that is carbon family, that is NH2 NP2. Fifth A group, that is nitrogen family. That means starting element only we are calling it as family. Okay, nothing else.
Sir,
Tell me, Nana.
so n will be same for both the suborbitals.
Ah, 1 is 2 because n represents number of period. So for example, to which period it is belong.
Okay, sir.
Okay. Next, sixth A group, that is also called as oxygen family. That is NH2 NP4. Next one, seventh A group, which is also called as halogens. Which will have NH2 NP5. General electronic configuration, valency electronic configuration. And next one, eighth A group, which is also called as inert gases or noble gases, which we can call it as a configuration is NH2 NP6. So from there, what we can write? General p block configuration is NH2 NP1 to 6. Okay. So
Sir,
likewise, we can, tell me, Nana.
sir, is this the valency configuration?
Yes, Nana. Valence electron configuration only.
Okay. Sir,
Okay.
P block configuration is general, sir, but all the families will have that configuration only, sir.
No, S
Exceptional
block
cases.
completely we are having different configuration. No,
No, sir, in
now,
P block.
in P block C we are writing NS2 NP1. No,
Yes,
for
sir.
car.
No,
This one will write, no, from all commoners I am writing NS2 fix and NP starts from 1 to 6. If you observe
sir,
clearly.
no, sir. My doubt is, for example, boron family, you wrote NS2, NP1, no, sir. All
Uh,
elements of the boron family will have that only, or
Same
exceptional
configuration.
cases
Only
is there.
period only it will changes.
Okay, sir. No exceptional cases.
Nothing, nothing.
Okay, sir.
Okay.
Yes, sir.
Done.
Yes, sir.
Uh, Next in the same way. Next one, no, in the same way. So in case of D block elements also there, no, the D block elements also we are having group 13 different it will be there. So that in all combinations I am writing general electronic configuration of D block I am writing. Okay. General electronic configuration of
Sir, groups means the horizontal, no, sir?
uh,
Groups means horizontal, no, sir?
group means vertical, no.
Okay, sir.
D block is will be n minus 1 D 1 to 10
Sir, NS 1 to 2.
ns 1 to 2 it will be there configuration. Okay.
Sir,
uh,
sir, so like D block means like D3, D4, right? Like
yes,
that.
yes, that configuration all.
Okay, sir.
Done. Done. Okay. Next. So in D block only, we are defining all the elements into series like 3D series, 4D series, 5D series. Likewise, we can define. Okay, that is if I am trying to show again, please see. These D block elements are there, no? See now, see here, scandium 21 to zinc 30. Can you see, Nana?
Yes, sir.
I'm not able to write something on this. Can you see SC, scandium?
Yes, sir. Sir, 21.
21 to zinc. This is called as 3D series. Okay, 3D series we can say, right? Next, this is called a 4D series. Yttrium, zirconium, niobium. This is there no 4D series. And bottom is there no hafnium, tantalum. This is all called as a 5D series. And this is called a 6D series. Sorry, 3D, 4D, 5D, 6D. Yes. Okay, na? Now in D block, so 3D series means from where to where we can write? 3D series frame is scandium 21 to zinc 30. 4D series means from where to we can write na yttrium 39 to yttrium, zirconium, niobium, molybdenum, technetium. Next zinc, cadmium. From where we can write cadmium 48, 39 plus 10, 48. Cadmium 48. Next 5D series. 5D series we are having lanthanum 57 and 58 to 71 lanthanides we can call, and after that hafnium 72 to hafnium 72 to what was zinc, cadmium, mercury 80. These are called 5D series. And 6D series means actinium 89 from thorium 90 to 103 called as actinides, and after that we are having Rutherfordium 114 atomic number to copper cesium 112. This is called series. That means depends on the element to which series it belongs. We can say 3D series, 5D series, like that we can write. Okay, this is about the D block elements. From this one only, if you are observe these elements configuration only, we will find like this. D1 to 10, sorry,
Sir, N-1.
n minus 1 only, that one I meant. And ns1 to 2. Okay. Next one, what we can say in F block. Okay, F block are inner transition elements. F block. General electronic configuration is F block general electronic configuration. What we can say? Do you have any idea? N minus 2, F1 to 14, N minus 1, D0 to 1,
NS1 to 2.
NS1 to 2. This is general electronic configurations. You need to remember. In F block only, we are having two series. No, that is F block only. We are having two series like how we are having. That is 4F series,
It-
which is also called as lanthanoids.
And next one, actinoids.
Lanthanoids, which is starts from lanthanum next cerium. Cerium 58 to cerium praseodymium to lutetium 71. Next 5F series. 5F series. Okay. This is also called as actinoids. Starts from
Protactinium, sir.
thorium 90. Thorium 91 protactinium. Thorium
Okay, sir.
92 uh, lawrencium 103. Okay, thorium 92. This is called actinides, and lanthanides and actinides together we are calling it as what we can say
F
inner
block.
transition elements, right? And moreover, these elements can be defined into what we can say metals, non-metals, and okay. So these all block elements, all block elements. They were broadly divided into divided into all the block elements broadly divided into uh, metals, non-metals, and metalloids. Okay, all the block elements broadly divided into metals, non-metals, and metalloids also we can define. Okay, and no metals and
Sir,
non-metals. This all no, Nana? I don't
Sir,
know.
it is divided into four, sir: metals, non-metals, metallites, and noble gases.
General noble gases. These gases we are not concerned with generally. We can write that. Okay, but I'm
Because
not
they're
already we
not
have discussed in
matching to
noble gases, no
anything.
inert gases. That's why I'm not writing. That's it.
Okay, sir.
Okay. Okay.
Sir,
Okay, Nana? Okay, students.
Yes, sir.
yes, sir. Sir,
Tell me, Nana.
sir,
Okay, na?
yes, sir.
Okay. So this is about the elements and classifications, Nana. Uh, okay. And next thing is
Periodic properties, sir.
next one. Next we need to go for the next one. See. Next point is periodic properties, Nana. Okay. Mm. So periodic properties. So periodic properties means the properties which show regular gradation in groups and uh, groups and proper periods. The properties which show regular gradation. Gradation means increase or decrease. Okay. The properties which show regular
Sir,
gradation. Tell me, Nana.
sir, if they ask any, for example, you have this D block electronic configuration. We know that it is we know the values of P and sir, we know the values of D and S. Then how will we know the value of N, sir?
Come again.
So like for D block elements configuration is in the configure. If they ask the question of configuration of D block elements, we know that we know S and D equals to S3 and D3. Then how will we know the value of N?
For example, if you are taking mm, for example, scandim if I'm taking, Nana. Okay. Hello.
Yes, sir.
If I'm taking scandium only. Okay. Let me write. Proper shows regular gradation in Let me finish this statement and after that I will write, right?
Okay, sir.
What are the properties we have generally? We have atomic size or atomic radius. Next, ionization potential. Or ionization energy also we can say. Next, electronegativity. Next, electron gain enthalpy. Okay, these properties we need to discuss now, nothing else. Okay, na? Now, tell me, my dear, what is your question? Hello, Nana, please ask you. Can you repeat that question? Student, please repeat. Hello, somebody asked me that question, no?
Yes, sir.
Tell me, Sharandeep, what was the question?
Sir,
How
for
to find
example,
out n for the d block elements? That is only,
yes,
na?
sir. Yes, sir.
See, for example, let me take a basic element I'm taking, like chromium. If I'm taking, which atomic number is 24? Atomic number 24. That means generally what is the configuration? We will write 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d5. Okay, na?
Yes, sir.
Now see here what we can say, this is the element. This is the, if we am rearranging, what we can write, 3s2, 3p6, 3d5, 4s2, no?
Yes, sir.
4s1, no? Now fourth cell will be the n and 3d. Now see, we are having, no, ns 1 to 2, n minus 1, d 1 to 10. See, n minus 1 means what? N is fourth cell and n minus 1 is third cell, no?
Yes, sir.
Understood?
Yes, I should write the first. You should write the electronic configuration of that element, and then you should find out the value of n, right?
Yes.
Okay, sir.
Without writing the electronic configuration, we can't predict only.
Okay, sir.
Then,
Yes, sir.
is it clear, Nana?
Yes, sir.
Okay. Now, generally, how to predict group number and period number for a, as you have asked, no? I will tell you that. Okay. Prediction of, so simple trick I will give you. Prediction of group number and period number. Group number and period number for a particular element. Okay, group number and period number for a particular element, how we can calculate. First, if the first we need to write the electron configuration. I told you as earlier. So without writing the electron configuration, we can't do. Okay, na? First, what we can write? Generally, you can predict the period number. Uh, the principal quantum number. Principal quantum number of the valency shell is period number. Is period. Okay.
Okay, sir.
Mm. Next, to which orbital the last electron enter. Okay, it belongs to that block. That means what we can say, for example, if the valence atom going to S block, then it belongs to S block element. If it is the electron configuration, now see here, okay, if it is entering into uh, D block, then it will be D block. Now see here, after filling S4s only, we will write D orbital, D configuration in this case. Yes or no?
Yes, sir.
That's why it is belong to D block elements. Okay, either groups for group, you need to remember this. For groups, if that element is S block, it will be one time. It will be P block, it will be one way. And if it is for one block, it will be one way. For example, in case of group, first one is for S block. Okay, for S block, group number is equal to its valence electrons. Valence electrons means you can identify, right? Next, for P block elements, group number is equal to ten plus valence electrons. Okay, you need to add 10. You need to remember none of this. For D block, group number వస్తుంది, సిక్స్త్ గ్రూప్ అవుతుంది కదా. గ్రూప్ ఫర్ గ్రూప్ D block elements. Okay, group number is equal to sum of electrons in nth cell and electrons in n minus 1th cell. Okay, this is what we can say D block elements. Is it okay, students? Students, okay, na? Now you can solve whether the element belongs to which group or which anything that we can predict, I think.
Yes, sir.
Thank you for asking me that question so that we can discuss this also. In next class onwards, we will discuss with periodic properties. So once periodic properties is done, topic is done for us. Okay? Okay, na students?
Yes, sir.
Okay, Nana. So we will meet you in next class. Okay? Thank you. Bye, all of you. Good night.
Thank you, sir. Bye, sir.